The world is on the brink of a large-scale catastrophe, and the search for an alternative energy is becoming more and more relevant every year. According to analysts, there will not be enough natural resources for a long time. Coal will run out in 50 years, and gas in 100. As you can see, the culture of mass consumption has led humans to monstrous consequences, from environmental pollution to the extinction of some animals. And in this episode today, we will discuss some large-scale projects that should save humanity from the terrible idea of a post-apocalypse world. Right now, the world is focused on building an international experimental thermonuclear reactor in the south of France. A number of countries are coming together to change the way our planet generates energy. With this 23,000-ton reactor, scientists plan to create a tiny star on Earth. How it will work. Hydrogen atoms are introduced into the vessel, and then a giant superconducting magnet around the machine is turned on. A voltage bounces the electrons off their atoms, forming plasma. This is a state of matter similar to a gas. The plasma is then heated to 150 million degrees Celsius, and at this temperature the atoms fuse together and in the process release a huge amount of thermal energy. This nuclear reaction produces 4 times more energy than nuclear fission and 4 million times more energy than burning coal, oil, or gas. It will be the largest and most powerful thermonuclear device in the world. The first launch of the ambitious project is scheduled for 2025. Speaking of large-scale projects on our planet right now, we should note the functioning solar park of Mohammed bin Rashid Al Maktoum, which is located in the Arab Emirates. The country's energy program aims to achieve energy balance by 2050, and the state is investing $13.6 billion in solar energy by 2050 to meet the growing demand for energy and ensuring sustainable economic growth. Anton Fedotov, project support engineer at Mitsubishi Power Europe. Why is it possible for the Arab Emirates to do this? Because they have a huge desert, and they clearly have a surplus of energy there. Nothing will ever grow in the desert, so there's no point in building anything in it. The first phase of 13MW was commissioned on October 22, 2013, and the project has contributed to a significant reduction in carbon emissions. It consists of about 153,000 photovoltaic cells connected to 13 transformers in inventory buildings. There's now 3 phases of the solar park in operation. The latest photovoltaic installation has a capacity of 800 megawatts. The company has managed to set a world record. 1 kilowatt per hour costs $2.99. Yes, that is what Europe is aiming at. They want to store energy in hydrogen, and they're buying a lot of hydrogen generating facilities. In Africa, which also has a lot of sunshine and very low energy consumption, the sun in the daytime when it shines covers the needs of the local population, and the excess goes to produce hydrogen. This solar power plant is the first of its kind in the Middle East and Africa. With an advanced solar tracking system, it's already producing 20 to 30% more electricity than stationary plants. Another country whose policy aims to achieve net zero goal is China. The goal of the People's Republic is to obtain 80% of its energy from carbon-free sources by 2060. At the moment, the project to produce solar, wind, and water energy is underway, but the Land of the Rising Sun has gone further and announced the launch of the first ever space solar power plant. The concept is to collect solar energy in outer space using satellites and distribute it back to Earth. Space solar power systems convert sunlight into microwaves that can be transmitted through the atmosphere to receivers on the Earth's surface. This project will help solve the problem with energy supplies, because the sun shines all year round, and satellites in orbit receive sunlight more than 99% of the time with greater intensity than solar panels on our own planet. The idea is to collect all this energy in orbit and direct it to a fixed point. We have wireless charging, which used to seem kind of crazy. If we can transmit energy to a half a meter, why not transmit it to 100 kilometers? Because the surface of the Earth is not really that far from space. The first launch of the Chinese project is scheduled for 2028. At the same time, a satellite test will be sent to orbit 400 kilometers away from the power plant to test the transmission technology. This satellite will turn electricity into microwaves or lasers and then send beams to different places. Years ago, flying was an impossible dream. Now we're successfully using this technology and developing an innovative, environmentally friendly flying machine. Industrial designer Oscar Winals presented a concept of a real flying castle, a multi-level supersonic passenger liner hyper-shaped plane Magnavem. The 70-meter plane, weighing almost 600 tons, will be equipped with a compact nuclear reactor, 4 massive electrohydrogen engines, and 2 ramjet engines. They will allow it to reach supersonic speeds of up to 1,850 kilometers per hour at altitudes of up to 15.5 kilometers. The capacity of this beast will be 500 passengers. The fusion reactor that will be inside will provide technology with an incredible amount of electrical energy. Fusion is a process by which gas is heated and separated into ions and electrons. When the ions get hot enough, they can overcome their mutual repulsion and not collide into one another. When this happens, they release a lot of energy, about 1 million times more powerful than a chemical reaction, and 3 to 4 times more powerful than a fission reaction. It's more efficient. It's about 4 times more efficient than nuclear fission. There's also a lot of advantages for this method. We have plenty of fuel, huge energy efficiency of the reaction, the power plant's based on controlled thermonuclear energy. They consume from the outside, and it can't lead to a second Chernobyl. But there's also one big problem. We still don't understand how to bring such a large amount of energy to at least come to zero, so the fusion reaction is self-sustaining. The creators from the apparatus hope to revolutionize the aviation industry with a compact fusion reactor, which should provide them with an incredible amount of electrical energy, all without any cost to the environment. What do you think of this? Is this the energy of the future? Let us know down below. Like this video and don't miss any new episodes from the world of high tech. Oh, and check out our PRO Robots Instagram page.